Imagine a student visualizing a massive, sprawling sci-fi city, but the moment they try to sketch it out, the vision evaporates into a blank page. The block isn't a lack of imagination, it's the technical threshold. They are asked to storyboard or design sets, but they hit a wall the second they realize they lack natural drawing skills. For a beginner trying to block out a scene, the thousands of menus, nodes, and polygons in standard 3D modeling programs act as a massive, impenetrable wall. The tools meant to bring ideas to life end up stopping the creative process entirely. The technical threshold is simply too high to cross, causing capable teenagers to shut down completely. Educational psychologists call this problem cognitive load theory, a framework explaining that human working memory has a strict limit on how much information it can process at once. When a student struggles with the mechanical effort of traditional drafting, holding a pencil, calculating perspective, or navigating complex user interfaces, that effort fills up their working memory. This is called extraneous load. Because execution takes 100% of their mental energy, there is zero capacity left for germane tasks, the actual intrinsic demands of the project, like narrative design, spatial planning, and lighting logic. As long as manual execution consumes a student's entire mental bandwidth, conceptual direction and creative problem-solving remain impossible. The prompt-to-presence workflow treats generative AI as an external processor, offloading mechanical drafting to free up cognitive load. In Phase 1, students bypass manual drawing, using text-to-image models to engineer prompts specifying lighting, anatomy, and composition for high-fidelity 2D art. Seeing a text prompt rapidly turn into a professional-grade image eliminates the excuse that they cannot draw. This immediate visual reward establishes generative self-efficacy, a psychological state where students build confidence in their technological capabilities through early, accessible success. This initial success shifts the student's role from a frustrated manual drafter to a conceptual director commanding the visual output. Moving from a 2D image to a 3D digital asset presents another hurdle. Traditionally, building a 3D model requires weeks of painstaking manual vertex manipulation. Phase 2 solves this by feeding the generated 2D image into an AI model called Trellis 2.2. Trellis 2.2 is a 4 billion parameter machine learning model developed by Microsoft that instantly converts 2D images into 3D geometry using a grid-like voxel representation. The AI reconstructs the complex 3D geometry instantly. This changes the student's core responsibility. Instead of building the model from scratch, they critically evaluate and refine the generated output. The machine hasn't removed the human from the work. It has replaced tedious mechanical construction with rapid, high-level critical iteration. In Phase 3, the 3D model is converted into a USDZ file. A USDZ is a specific file format that allows digital objects to be easily projected into the physical world using augmented reality. Projecting these models into the classroom introduces a new risk. Forcing a beginner to navigate complex spatial hardware could overwhelm their cognitive load all over again. To prevent this, the instructor acts as a virtual camera. Wearing an XR headset, the teacher absorbs the software's operational and interface burdens. With the teacher handling the tech, students are completely free to walk around, critique, and spatially annotate their models at a scientifically accurate full scale. This frictionless, embodied interaction finalizes the transformation from an isolated digital file into a true volumetric presence that the entire class can experience together. Compare the initial frustration of a blank page to a student confidently manipulating glowing, floating 3D assets inside a vibrant high school classroom. This empowered state is known as algorithmic authorship. It's the unified cognitive act of deliberately directing AI as a creative instrument rather than passively accepting its default outputs. This classroom success mirrors the professional media industry. Film, animation, and game development are currently undergoing an algorithmic renaissance, heavily integrating these exact AI-accelerated pipelines. Because of this shift, modern career readiness and digital fluency no longer prioritize manual drafting speed. Instead, they demand the ability to ideate, curate, and collaborate effectively with artificial intelligence. Generative AI tools do not replace the human creator. They simply remove the friction between human imagination and physical reality, democratizing complex creation for everyone.